Equation of differentiation. Two concepts. Definition. Definition. First derivative test. First derivative test. First derivative test. Okay. Let f be a continuous at x naught. F be continuous. ETS continuous at x naught. X naught. In a comma b. Subset of domain of f. Domain of f. Subset of domain of f. Then for 0 less than mod x minus x naught less than delta. Then we have the following. First one, have the following. F of x naught is relative maximum value. F of x naught is relative maximum value. Relative maximum value of f. If f dash x is greater than 0, f dash x greater than 0, and f dash x f dash x less than 0 for x greater than x naught. For x greater than x naught. Second one. F of x is a relative minimum. F of x naught is relative or local same. Relative minimum. Relative minimum value the minimum of f if f dash x less than 0 for for, for x less than x naught, x less than x naught, x less than x naught, and, and f dash x, f dash x greater than 0 for x greater than x naught, x greater than x naught. X, f of x naught is neither relative maximum, f of x naught is neither relative maximum, maximum value, value, not relative minimum value, not relative minimum value. Not relative minimum value. If f dash, if f dash x does not change the sign, does not change the sign, change the sign, does not 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 change. No, f of a is relative maximum if f is continuous at a, and if f changes sign from positive to negative at a. F of a is relative maximum if f is continuous at a, and if f changes sign from negative to positive to a, positive to negative, positive. So one example we'll discuss based upon this concept. Find the maximum and the minimum of, find the maximum, minimum, find maximum and minimum, find maximum minimum of f of x, f of x equal to x minus 1 whole square, x plus 1, x plus 1 whole power minus 3, power minus 3 over 1 comma infinity, 1 comma infinity. F of x, f of x, what is given? X minus 1, x minus 1 whole square into x plus 1 whole power minus 3. So f dash x equal to, f dash x equal to x minus 1, x minus 1, x minus 1 whole square into minus 3 into x plus 1 whole power minus 4 plus x minus 1 whole power minus 3 into 2 into x minus 1, 2 into x minus 1. So on simplification we obtain x minus 1 into x plus 1, x plus 1 whole power minus 4, x plus 1 whole power minus 4, so into 5y minus 5 minus 5 minus x. 5 minus x. 5 minus 5 minus x. So therefore, for maxima or minima, f dash x equal to 0. F dash x equal to 0. That implies x equal to 5. X equal to 5. F dash x is greater than 0. F dash x is greater than 0. F dash x is greater than 0. For x is lies between 1 and 5. 1 less than x less than 5. F dash x is less than 0. So f dash x is less than 0. Well, x lies to 5 to infinity. 5 less than x less than infinity. By first derivative test, f of 5, by first derivative test, derivative test, first derivative test, f of 5 is the maximum of m. The maximum of f, maximum over 1 comma infinity, or 1 comma infinity, and f of 5 equal to f of 5 equal to 5 minus 1 whole square, 5 plus 1, 5 plus 1 whole power minus 3. On simplification, we obtain 2 by 27. Okay. So to calculate local maximum, or minimum points of f, we must consider the following candidates of choices. Any interior point, domain of f, and next, second derivative test. Next concept is second derivative test. Second derivative test. Second derivative test. Second derivative test. Okay. Let f be a function at x naught. Let f be a function, be a function at x naught, in a comma b, is domain subset are equal to domain of F. Subset are equal to domain of F. Domain. From first condition. Domain of F. So if F dash X not equal to 0, if F dash X not equal to 0, X not equal to 0, F dash X not equal to 0, F dash X not equal to 0, and F double dash and F double dash X less than 0, then F of X naught is, then F of X naught is, F of X naught is relative maximum value, relative maximum value, relative maximum value, relative maximum value. Second one. Second. If F dash X naught equal to 0 and F double dash X is greater than 0, then F of X naught is relative 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 minimum relative minimum value, relative minimum value, relative minimum. Suppose third one, if F dash X naught equal to 0 and F double dash X equal to 0, F dash double dash X equal to 0, then F of X has, of X naught has neither maximum, neither maximum nor minimum, nor minimum, nor minimum value. This stage is known as point of inflection. In this case, we say point of inflection, point of inflection, point of inflection, inflection. For example, will you based upon this? For example, page number 221, example. Example. Examine the polynomial function. Examine the polynomial function. Page number 223. Find the maximum and minimum values of find the find the maximum and minimum values maximum and minimum values of f of x, that equal to ax square plus bx plus c, where a is not equal to 0. Solution. Solution. For what? Therefore, this point is minus b by 2a. Point is minus b by 2a. F of minus b by 2a. A less than 0. Y equal to f of x. Y equal to f of x. Relative maximum. This is known as relative maximum. Relative maximum. Y equal to f of x. Y equal to f of x. F of minus b by 2. Relative minimum value. Relative minimum value. Minimum value. Relative minimum value. Relative maximum. So the given function f of x. The given function f of x, that equal to ax square plus bx plus c. That means f dash x equal to 2ax plus b. if f dash x equal to 0, yet x equal to minus b by 2a minus b by 2. If a less than 0, a less than 0, f double dash minus b by 2a minus b by 2 less than 0, and hence hence f of minus b by 2a minus b by 2a is relative maximum at is relative maximum at to maximum relative maximum at x equal to minus b by x equal to minus b by 2. If a is less than 0, f double dash x double dash b by 2a f double dash b by 2a greater than 0, and hence f of minus b by 2a is relative minimum 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 get x equal to minus b by 2a. So also f of minus b by 2a minus b by 2a equal to 4ac minus b square by a minus b square by 4a b square by 4a. So if a is greater than 0, if a is greater than 0, a is greater than 0, a is greater than 0, x less than minus b by 2a That implies f dash x is less than 0 and x is greater than minus b by 2a. That implies f dash x greater than 0. F dash x greater than 0. F dash x is greater than 0. So f is decreasing minus infinity to thus f is means function is decreasing. 10 marks question, most important is decreasing in minus infinity to minus b by 2 minus b and increasing and increasing and increasing in minus b by 2a to infinity. Infinity. So maximum in this case is plus infinity. Hence the relative maximum at x equal to minus b, the minimum value of f. Further, now f has no maximum value and minimum value. In this case, limit x tends to infinity plus infinity. F of x not equal to plus infinity. Limit x tends to minus infinity. F of x that equal to minus infinity. That means neither maximum nor minimum. Either maximum, the function has neither maximum nor minimum nor minimum nor minimum nor minimum. So next, concavity and convex. Concavity and convexity. Concavity. Page number 230. For convexity. Concavity and convexity. If f double dash is positive in an interval, if double dash f of x is positive in a comma b, means equivalent to interval, then f dash increases there. F dash increases there. Increases there. Increases there. Increases there. In other words, x is increases. The slope of tangent to the graph at the slope of tangent, the slope of tangent, yet the slope of tangent to the graph, graph x comma f of x comma f of x increases, 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 so that the tangent turns counterclockwise. So that tangent turns counterclockwise, clockwise, counterclockwise, counterclockwise, or positively. There, this affects in the graph bending upward. This affects affects in the graph bending upward or bulging downward. Bending, bending upward, bulging, bulging downward, bulging downward, bulging downward. Such graph and functions are known as convex. Such graph and functions. Fn means functions known as convex, known as convex. Known as convex. The terms concave upward, convex downward are also the terms. The terms concave upward, concave upward, concave upward, convex downward, convex downward, convex downward are also used for this. Used for this. For this. Used for this. Used for this. Such functions known as graph. One, first one. Similarly, f is f tabular negative, it decreases. Graphs are drop below the chord AB above the tangent. AB is the chord. The first one. Similarly, if f double dash is negative in the interval closed interval a comma b, then f dash decreases and hence slope of decreases. The tangent turns clockwise. Such functions are known as concave, and the slope is decrease. So concave downward, and convex is upward. Hmm. Definition. 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 For the graph of the function. Graph of, of the function. Y equal to f of x. Okay. The curvature at a point, the curvature at a point at a point, the curvature at a point, x naught comma f of x naught, f of x naught is defined as is defined is defined as is defined as kappa of x naught, kappa of x naught. This is not k. Kappa you have to learn from. You have to read as kappa. Kappa means Greek alphabets. 24 are there, no those. That one. Kappa of x naught. Kappa of x naught. That equal to f double dash x naught whole divided by 1 plus 1 plus f dash x naught whole power 3 by 2. 3 by 2. That implies kappa of x naught, kappa of x naught equal to y2 means f double dash x. That means y plus y1 whole power 3 by whole power 3 by 2. Okay. We denote the curvature by curvature kappa of x naught. Read as k as read as kappa in geometrical terms. In geometrical terms. In geometrical terms. geometrical terms. Cup of x naught means curvature of x naught equal to ds by ds by d psi ds by d psi, where s is the arc length of where s is the arc length of y equal to f of x. Y equal to f of x. And psi psi is the angle the tangent is angle the tangent angle the tangent angle the tangent at x naught comma f of x naught f of x naught f of x naught makes with the positive real axis the radius of curvature at the radius of curvature the radius of curvature the radius of curvature at x naught comma f of x naught f of x naught makes with poem f of x naught is denoted by is denoted by rho of x. This is read as rho of x. Rho of x defined rho of x is defined 1 by cup of x naught cup of x naught cup of x naught. If cup of x naught if cup of x naught is not equal to 0 not equal to 0. So you will observe the radius of curvature positive function is convex at the point that is negative if the function is concave there. So using this one, we find one example. Page number 231. Example. Find the curvature of the straight line. 6 marks questions. Find the find the curvature of the straight line. Curvature of straight line. Straight line. Straight line. Curvature of straight line. Y equal to mx plus c is slope intercept form. At a point on it, at a point on it, a point on it, a point on it. Let P be the point on line. Let P be the point on the line. Point on the line. point on the line. On the y equal to mx plus v. Y equal to mx plus y equal to mx plus. We have dy by dx by dx equal to m d square y by dx square d square y by dx square is 0. So curvature at therefore curvature at k k of x naught that equal to 0 divided by means y2 means actual formula is y2 by 1 plus y1 square 0 divided by 1 plus y1 square whole power 3 by 2 nothing but 0. Thus curvature at any point on the line is thus curvature any point on the line any point on the line line is 0 is 0. Center circle center page number 234 1.6.4 important for 20 marks question. See, so center circle of curvature and evolutes. Center circle of curvature, circle of curvature, circle of curvature and evolutes. And evolutes. 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 Characters and evolutes. Definition. Definition. Let y equal to f of x be a curvature. Y equal to f of x be a curvature. Be a curvature. Page number 234. Page number 234. Page 234. 234. Page number 2. Curvature. Curvature. Be a curve. And P be a point on the curve. PBA and PBA. PBA. Point on curve. Point on curve. Point on curve. Let the curve have curvature kappa at P. Let the Curve has curvature, curvature, curvature. K at P means kappa at P, kappa at P, kappa at P. The circle touching the curve, the circle touching the curve, the circle touching the curve, the circle touching the curve. Y equal to f of x, y equal to f of x at P, having the same curvature K, having the same curvature, curvature, having the same curvature, curvature, K at P means kappa at P, at P, curvature at P. And lying on the same side of the tangent, and lying 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 same side of the tangent, side of the tangent, same side of the tangent, same side of the tangent, same side of the tangent. Get P. As the curve lies is called oscillating circle. As curve lies is called oscillating circle or the circle of curvature, oscillating circle or circle of curvature, circle, circle of curvature, curvature, circle of curvature. So y equal to f of x at p. The radius of this circle curvature becomes 1 by k. So we call this radius of the curvature y equal to f of x, denoted by rho. So rho equal to radius of curvature, circle of curvature. Rho equal to 1 by k. Then the center is called the center of curvature y equal to at p. So p is the point, is center of the circle, center of curvature, center of curvature. So you have to read the definition 10.6.2, definition 10.6.2, and example 10.6.4. Homework. Now this is for 10.6.4 is section C. important for 20 marks. 20 marks question. Okay, this is 20 marks question. No, now they will leave the way. 20 marks question. You have to practice. Most important. In 20 marks question, third, first, second, third is also you need to write. Then only they will give 20 marks. Otherwise, what is that question? Calculate the radius and center of the curvature. You will use the hyperbola. So definition and example is 20 marks questions. Okay, I'm leaving. Thank you very much. All of you understood? Last 10.6.4 is important for 20 marks question. Have to practice. If you have any doubt, ask me tomorrow. Class is there, no? Okay. Thank you. Leaving.